Now, the architecture editor allows you to create component diagrams, UML component diagrams, and that's selected from the Create menu of AgileUML in this option, Architecture. So that brings up an architecture editor in which you can create components by clicking on the location in the screen. Creates UML component. For that we can create provided interfaces and click on the component and drag to where you want the provided interface. Now that provided interface doesn't need to already exist. If it's not already existing, then it will be put into the class diagram as an interface here. And it's going to be an empty interface. Obviously I can edit that interface. I can add operations, so with the usual kind of editing in UML RSDS, in AgileUML we can add operations with whatever parameters. Let's say it's got one integer parameter and one output parameter, and we can leave it undefined as it's in the interface. It's not going to have any implementation, and in fact you could write it as abstract, I suppose. So that's our provided interface. You can add other provided interfaces as well. A component can have any number of provided interfaces. And it can also have required interfaces. The required interfaces are things that it needs from other components. Now we can have several components and we can connect them together. So the usual way to connect components is by an assembly connector. So we have a component C2, and this provides something that C1 requires. Now there's two ways to do this. If you give the same name R1 to this provided interface, then the system will be happy, and it will basically say, well, it's a valid assembly connection because we're linking the same interface here on the provided and required side. But it doesn't have to be that way. You could actually have different interfaces there, but then you've got to ensure that everything that's needed by the required interface is available in the provided interface. Essentially, the provided interface has to be an extension of the required interface in object-oriented terms. So we can do that. Let's have another example then. So we can have required interface R2. And this provides a provided interface let's say P3. Now, at the moment that's valid because both those interfaces are empty, but obviously that's not a realistic situation. I can clean up this diagram to make it more attractive, make it more clear. Now those interfaces R2, P3, let's say R2 is non-trivial, so let's have a look at R2. It's actually easier to edit these using the KM3 editor, the text editor. So let's say R2 requires this same operation. So R2 requires an op1. So now R2 has this. Again, this diagram can be moved to make it more clear. And now if we look at this one and we look at what components are there, then we've got component with C1, component C2 with their different interfaces. The checking, I think we can check interfaces. You can also derive Java, in fact. But basically this is no longer a valid interface. This is no longer a valid connection because R2 needs more than P2 provides. So in order to make that a valid interface, valid connection, I've now got to go back to the editor here, and I've got to provide in P3 everything that R2 needs. I could provide extra things as well. I could have an operation 2 that takes a long, let's say, it's a different operation. So then I've got a class diagram with this interface and that interface there. And now that's this is all a valid connection.